1 second. Okay, so let's start this off by just redrawing the unit circle and everything like that. Okay, so the unit circle, let's use black. Okay. So all you need to remember is really just one quadrant, this quadrant, and then the rest you should be able to kind of think about. So I'm going to call this 0 to pi, and let me just draw this line, this line. Do I have one more? Yes, I do. Right here. So this angle, pi over 6, and we're only going to go radians here, because everything will be really just done radians from now on. Pi over 4, pi over 3, and then this will be pi over 2, right? So note that pi over 6 corresponds to this line, pi over 4 corresponds to this line, and so on, right? So that's the idea that's going on here. So if we think about this triangle, and I just have it memorized here, honestly, I do. And then I'll write this in blue, square root 3 over 2, 1/2. Then this guy's always going to be square root 2 over 2. So whenever you see a pi over 4 or 2 pi, or 3 pi over 4, any number pi over 4, it's always going to be square root 2 over 2. It just depends on if it's a negative or positive. And we'll get into that in a second. Whenever you see a pi over 6 or some sort of variation like that, it's always going to be square root 3 over 2, then 1/2. And for pi over 3, it's going to be the opposite, where it's going to be 1/2, then square root 3 over 2. So any sort of variation like this, these are the only coordinates that are going to come up. Now, the rest is just, it's going to be negative, either over here, the negative x and y, positive x, negative y. So that's what you have to remember. But the angles are kind of hard to start thinking about. So we get this. Okay. So this angle, let's call this guy, what should we call it? Well, first off, let me just label this as pi, right? So I'm going to go up from pi. That's 5 pi over 6. Then this guy will be what? 3 pi over 4. Next one will be 2 pi over 3, right? And then, yes, we can write pi over 2 again, just right next to it. This for it to make sense and be clear. Okay. And then look at this. I'm really just going to copy exactly these guys over here, put them over here, but I'm just going to add negatives, respectively. And where should the negative go? Should all go on the negative x, right? Because this is the negative x coordinate, right? This is the negative x coordinate. It's still positive, right? It's still positive vertically, but it's going this way. So if it's going this way, then it's negative, right? Okay, there we go. Again, let's think about this, right? So I'm going to call this guy, this is pi, and this is one more pi over 6 than pi, which is 7 pi over 6. Then this guy has to be what? Again, some sort of variation of 4, call it 5 pi over 4. The next one, let's just think about it. If everything is just 1 over what its denominator is, and then this is a 3, so this is what? 4 pi over 3. And then this guy will most likely be what? 3 pi over 2, right? Of course. Okay. And note that, again, it's really like the same coordinates and everything like that. It's just now we got to add the negatives to both the x and the y, because this is the negative quadrant. Everything is negative in this quadrant. Okay, so what do we get? Square root 3 over 2, 1/2. Negative, negative, though. Then we get negative square root 2 over 2. Negative square root 2 over 2. Negative, negative, right? And this guy is going to be negative 1/2. Negative square root 3 over 2. There we go. Oh yeah, and of course we should write out this coordinate as well, which is 0, 1. And we know that this guy is 1, 0. And pi corresponds to negative 1, 0. Thus this guy corresponds to 0, negative 1. Okay. And here's the last part. So this is where I like to think of right here. We're almost at 2 pi, but we're pi over 6 away from it. So this must be 11 pi over 6. So it's nearly almost 2, but then minus 1, right? 3 pi over 2. What's this one then? So if this guy's 4 pi over 3, then this guy's most likely what? 5 pi over 3. And if this is the 4, then this guy must be 7 pi over 4. Right. Oh, 1 second. Let me just put the 5 pi over 3 here and 7 pi over 4 here. 3 pi over 2 like that. Just so it stays consistent, it looks more natural. Same thing again, coordinates, right? Like what's going to happen? It's literally going to be identical. Except all the x's are positive here, all the y's are negative. So 1/2 negative square root 3 over 2. Square root 2 over 2. Negative square root 2 over 2. Then, what's this one? Square root 3 over 2. Negative 1/2. And there we go. We drew the unit circle, and now we can start all of our other problems. Let's enlarge this guy. And we could always flip back to unit circle. Okay, sine 2 pi over 3. Let's go back a second. This guy right here. This guy right here. The sine corresponds to this. So, square root 3 over 2. And sine negative 2 pi over 3. We'll go back. What's a negative, right? So, this is the positive way, because we're going counterclockwise. So, the negative way from here would be right here, right? This guy, right? So positive's going this way, negative's going this way, or you could just do the plus 2 pi or minus 2 pi trick, whatever you want to do. But sometimes it's easier to think about which way it's going. And sine will correspond to negative. So this would be negative square root 3 over 2. And what's this? This is negative 3 over 4. Alright. Now let's just check the answer. They're gonna show the answer. Yeah, square root 3 over 2. Yeah, they didn't. Oh, okay, my bad. 1 second. I thought they were saying multiplied. Instead of and, we're gonna write multiplication. Just to make it just a little bit harder, right? Make it a little bit more fun too. Okay, cosine 7 pi over 6. Where's that? Okay. So, boop, 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 boom. Here, it's this angle. What does it correspond to? It corresponds to these coordinates. And then cosine, we could read off it as negative 3 over 2. Negative square root 3 over 2. And what's the other guy? Negative 7 pi over 6. So, let's just take a guess real quick. I'm guessing it's like this. And yeah, you could go to Lamar's math notes and it'll tell you about the odd and even functions, right? This type of stuff, and how that works. But you could also think about it just, again, like I said, we went this way originally. Now we're just going to go this way originally, and look at that. It corresponds, boom. Right? Oh, yeah, wait, actually. Let's just test this. It's a cosine. Cosine. My bad. So cosine negative 7 pi over 6 plus 12 pi over 6 is cosine 5 pi over 6, which is, yes, negative square root 3 over 2. Oh, yeah. There we go. Everything's correct. My bad. I ended up looking at this guy. Like, my eyes got confused. Everything's good. It's just 3 over 4. That's your answer. But it's a good way to double check. Okay, let's do these guys. And let's do negative pi over 4. Let's just open up a new tab of this. Negative pi over 4, we can start here and then just go boom. That's the same thing, 7 pi over 4. Okay, this will be our reference tab. So tangent negative pi over 4. Tangent of pi over 4 anything is always what? Like tangent of pi over 4 anything is always 1. So if there's a negative pi over 4, then we know it's also going down this way. So it's going down this way, so now it's in a negative quadrant. So it's in this quadrant. This is a negative quadrant, right? Because there's this, right? The y's are negative. So in other words, it's negative 1. Tangent 7 pi over 4. That's the exact same thing. Oh. That's the exact same thing as tangent 7 pi over 4. It's 1. Sine 9 pi over 4. Okay, let's just... I don't really think it's sine 9 pi over 4, but I see this as sine, what? 9 pi over 4 minus 2 pi, which is 8 pi over 4, which is sine pi over 4. And we all know that to be square root 2 over 2. Oh my god, I keep messing this up. Secant. Secant 25 pi over 6. I have no idea what that is, right? So how many times should I minus? Let's just minus, let's think about this actually. 25 pi divided by 6, I could divide that 4 times and get 1 remainder. Right? So, in other words, this is 4 pi over 6, right? That's how it works. I forgot how mixed numbers work. 24, yeah. There we go. This is the exact same thing. This is a mixed number, not a multiplication. So I know that it's just been around the circle 4 times. In other words, this is the same thing as pi over 6, right? And just to prove it to you real quick, we'll do 25 pi over 6 minus, we'll do this 4 times. So minus 12 pi 6. Ah, my bad. Sorry, my bad. I kind of explained things wrong here. I forgot that the unit circle goes by 2 pi, not just pi. My bad. Let's just do this old-fashioned. Secant 25 pi over 6 minus 12 pi over 6. That is equal to secant, what? 13 pi over 6. And then now let's minus off something again. Right? So yeah, what I did earlier was like a little bit of a fancy trick. I didn't explain that well, and I also kind of got lucky a little bit. But I did see it to be secant pi over 6. And we know secant pi over 6 to be what? 1 over cosine pi over 6. We know cosine pi over 6 to be 1 over root 3 or 2. Thus this is 2 root 3. Alright. Oh my god. Tangent 4 pi over 3. Like we can literally just go right here. So negative 1/2, negative root 3 over 2. Let's just write that coordinate real quick. Then we know it's y over x, right? And again, I always like to show people that you can rewrite this as what? There you go. So that's very useful, right? Okay, I don't know if I taught you much about, or if you learned anything about inverse functions, but we're going to do it now, because so far we've always been going like this. We say sine theta is equal to, what, opposite over hypotenuse, right? And that always is nice because we're always given what? We're always given the angle. So we are always given, we usually have the angle. But what if we have the lengths? What if we have the lengths? What if we have the lengths and we want the angle? Alright, so what do we do then? Well, then we take the sine inverse. We go sine inverse of opposite hypotenuse equals theta. And what does that really mean? Like that whole idea of sine inverse, like it's what we're saying is now we're swapping our input and output. And if we do that, then we have to change the function. So it goes from a regular function to an inverse function. Okay, so maybe this will be easier to explain to you like this. Y is equal to f of x. The inverse, right, if we do inverse, then we go x is equal to f of y, right? That's the opposite way. It's the inverse. But you may also see it written as, yeah, we're just going to leave it like that. But you could see things like y, f inverse of x. But it's kind of a weird notation to write, so I'm going to erase it. Just think about it this way. They're swapping inputs and outputs, okay? But if you do that, you have to fundamentally change the function, especially for trigonometry. Sometimes in algebra, you can actually, there's a lot of algebra where you can keep the function the same and swap the inputs and outputs. But that's a little bit advanced. Let's do some examples here. Well, some easy examples. Okay. We're going to call this pi over 6 because we're so familiar with that. 1/2 square root 3 over 2 and 1. Right? I just stole this from the unit circle. That's all I did. Right? So if I ask you, what is sine of pi over 6? You run and you tell me it's exactly, I know it to be, what? It's opposite of our hypotenuse, which is 1/2 over 1, which is 1/2. If I ask you to tell me what's cosine of pi over 6, you run and tell me, you say it's square root 3 over 2 over 1, which is square root 3 over 2. You tell me that every single time. I know you can. But what if I asked you, what is sine inverse of 1/2? And it's easy to say right now that, oh, sine inverse of 1/2, what is that? Well, then it has to be pi over 6, right? So it's easy to say things like that when you know the unit circle. That's why I preach the unit circle so much, because if you know this, then you can know like if you know the regular unit circle, then you know the functions that correspond within that unit circle. And then if you know those functions, you use them so much, then eventually you'll know the inverses just as well. Okay. And then if I was to ask you what's tangent inverse of, let's think about this. I kind of gotta do this a little bit in my head here to make this. If I ask you what the tangent inverse of that is, that's a little hard, right? I mean, that's a little bit easier than if I was to ask you what the tan inverse of the tan inverse of 1 over square root 3 is pi over 6. And let me prove it to you. Let's just do tan of pi over 6. We'd write that to be what? Opposite over adjacent. So it's 1/2 over square root 3 over 2, which is 1 over square root 3 over 2. So now you can see that like you can see that symmetrical, not symmetrical, you can see that inverse property being used right here. Tan inverse 1 over square root 3. Right, so like a lot of times these are confusing because it's like nobody has that perfect picture in their head unless they've been doing it for a long time. So I don't expect you to get it always correct. In fact, I actually would be surprised if you get it always correct if you know all these inverses and everything like that, because it's going to take a while. But you're going to try to expect me to do them, so here we go. I'll try to do these without cheating and using the unit circle. By the way, cheating is using the unit circle is not cheating. I always want you to use it, because if you don't know it by heart, then you're just making things up, right? Okay, cosine inverse of sorry, I'm gonna cheat just a little bit. Just a little bit. Just a tad bit. This is like severely cheating. At least because well, cheating for me. Literally, everybody else should do this though. Okay. And then I could just write this as yeah, there we go. So cosine inverse of square root 3 over 2, right? That's asking me what angle, if I'm going to say if cosigned, if that makes any sense. If cost, and we go like that, if cosigned, what angle, instead of writing angle, we'll use the symbol, what theta, if cosigned, equals square root 3 over 2. It's pi over 6. Okay. And then let's just check. Cosine pi over 6. Oh, yes, we know that's a b squared root 3 over 2. So, this guy is what? Pi over 6. Okay. Same question. What angle, if cosigned, is negative square root 3 over 2? And let's sort this into what theta, if cosigned, is equal to negative square root 3 over 2. So, the positive one, positive pi over 6, corresponds to positive this. Negative square root 3 over 2, I know that's going to be on the other side, right? It has to be on the other side of the unit circle because it's a negative x. So there's technically two solutions here, right? It's wherever cosine is negative square root 3 over 2. So that happens at 7 pi over 6, right? Happens at 7 pi over 6 and also happens at 5 pi over 6. Okay. And by the way, pi over 6, that's not the only answer as well, right? It also happens at negative pi over 6. It also happens at 11 pi over 6. It could also happen at 23 pi over 6, right? Because remember, it's a circle. So I'm only going to stick to like the normal numbers on the circle. I'm not going to try to confuse you. Inverses are very confusing for a lot of people. Okay, let's ask the other question again. What's theta if signed equals negative 1/2? So where is my height going to equal negative 1/2 on the unit circle? So it's definitely not the top part of the unit circle, right? Definitely not the top part. Erase the top part. Now it's on the bottom part. So where does sine equal negative 1/2? It's where theta. Oh, look at that. It's the same answer, right? Well, at least, no, it's not exactly. It's 7 pi over 6, and it's 11 pi over 6. And if you don't understand what I'm doing right now or how I'm getting these answers, that's totally fine. What I want you to do is check them, right? Check them like how I did right here, okay? Like I said, like I have the unit circle really just burnt into my head. That's the only way I'm able to do these. Okay. What's theta? Let's just say what's theta if tan is equal to 1? So where does tangent equal 1? Well, I know it equals 1 wherever the y and the x are the same. So, but it's positive 1, right? So there's only two parts in the unit circle where that can happen. This guy and this guy. And the only parts where equals 1 is right there and right there. And those angles are theta is equal to pi over 4. And what's that? The other angle. That would be 5 pi over 4. Okay. And now we're starting to get in the funny territory. So it's like, I call it the funny territory. It's like, so cosine inverse of cosine theta, what do you think that is? I don't know, right? Or what do you think cosine of cosine inverse of theta is? Is it just theta? Or, like, what is this? Is this theta? I don't know, but I don't have everything memorized. But let's just check this. Let's check this for fun. Well, actually, let me do it legitimately first, and then we'll check and see if there's some secret tricks. Because I know there is actually some secret tricks. I just forgot those. Okay, cosine inverse. First, let's ask, what's theta if cosine is equal to square root 3 over 2? Right, so the first part we're going to do is just this guy, and that's why I wrote this question. And did we answer that question already? We did, right? So it's when theta is equal to these guys, right? We'll just write pi over 6 and 11 pi over 6. So that's that. And then we ask, okay, then what's cosine of these angles? What's cosine of 11 pi over 6 and cosine pi over 6? Okay, and then we know those to be equal to what? Square root 3 over 2, right? So, in other words, cosine inverse of, and I'm just going to say number here, okay? Let's call it a number, right? Because it is a number, is equal to that number. Okay, so there's the trick. That's pretty cool. Okay. And what about sine inverse? Do you think it's the same trick? I don't know, right? Cosine and sine, they're pretty similar, but sometimes they're completely different. Like, we don't know. So let's just ask the simple question again. What's sine pi over 4? Well, that sine pi over 4 is 100% square root 2 over 2. And then we just ask, that's the next question, what's theta if sine is equal to square root 2 over 2? Well, we know it has to be theta is equal to pi over 4. And one second, pendant update right here on your screen. It's on my tablet, but it's not on your screen. There we go. So what's theta if sine is equal to square root 2 over 2? Well, we know that angle has to be pi over 4. We also know it has to be, what? 3 pi over 4. Right? Those are the two answers. Okay, so in other words, again, let's see if there's a trick that we saw or a pattern. So you take the sine. Yeah, so again, in this case, you know, we had one input here and then we got two out, like we got two answers, right? And this makes sense, like, because the theta does actually equal that, right? The question says sine pi over 4 is square root 2 over 2. So that's your only answer right there, right? But then now it's saying sine inverse of square root 2 over 2 is what angle, right? And then there's two angles. So it's kind of a funny situation where you get one input and then you get two outputs. And again, this is very confusing for a lot of people. Still gets me tripped up a lot of times. But the best way you can get good at this stuff is you draw this thing not this one. You draw this guy over and over and over again. And then eventually every single part of the unit circle will be ingrained into your head. And you'll just know, like you'll know these guys by heart. You'll know them within seconds. Right? I don't know why there's a 2 missing here. You know there's a 2. Inverse functions, I really went through this kind of fast to be honest, but there's not much to it. There's no secret learning besides just the memorization of the unit circle. Like, I hate to say that. So this is really it. But what helps is if you ask yourself these questions like I do. Say, what's theta if cosine is equal to square root 3 over 2? Right? You have to kind of go back and fill in that missing piece of information. Okay, Kara, I hope you do well on your tests and everything like that. This is a 30-minute video, but this will probably take about an hour to actually go through and analyze and learn. So have a good day, have a good night, whenever you're watching.